Good evening and good morning because we have participation across the globe. I am Rahul Bagadia, Managing Director at P Manifold, and I welcome you to this very new and fast growing electric boat segment, uh, electric boats. The topic of today's webinar is electric boats, emerging needs, opportunities, and feasibility. And with this topic, P Manifold is glad to also launch its new initiative, Hash Grow Electric Boats. This is part of our global initiative, India and Global Charging Ahead. And I welcome you all for this discussion today. Let's first very quickly understand why are we looking and what is the need for transition to electric boats. The foremost reason comes out as emissions, with China, US, and India contributing to highest three emitters globally, and shipping constituting 2.6% of global emissions on the transportation side. And within that, the bigger ships, bulk carriers, oil tankers, they contribute 55%. So this is one of the major reasons to look on for electric boats to reduce the emissions, reduce the fuel spillage, low noise of electric motors that will add to our sea river sanctity. On cost front, with fuel prices rising, with falling solar and battery prices, the economics of electric boat is really kind of coming in favorable range for various applications. And actually today with our speakers and experts, we will discuss what applications are really ready to go electrification in now and short medium term. Of course, electric boats, like any other EVs, offers advantage on operations and maintenance in terms of high reliability, and in case of boat space, quite easy retrofit. These are different ship types which are getting used globally. Interesting research done. It also shares the volume of contribution to the travel and logistics. On the top, we have containers and tankers. Then we have passenger ships and cruisers. And on the below side, you will see the smaller unorganized fishing vessels there. Worldwide, if you see e-boat market is growing at 11% CAGR, expected to reach 14 plus billion opportunity by 2023, with primary market capture first coming from USA, followed by Europe and Asia Pacific. So here is where we should see more of e-boats. And within existing fleet of e-boats, hybrid has taken a wider share, primarily coming because of lower range and speed limitations from pure electrics. But you will hear with our experts today that how pure electric is really also emerging fast in terms of technology developments. There are more than 100 players since 2000. There has been momentum going around electric boats, and small boats with 10 passengers and below, they are the largest sales and market capture in the broader e-bus segment. Some of the barriers, again, our speakers will discuss in more details, coming from low speed, limited range, lesser trials because still there are limited number of global pilots happening, high upfront cost. Financing is still a major issue, more so in the EVs, but it expands also to the e-boat space. And primarily complexities in charging and renewable integration. We'll learn more about it, how versus onboard versus port batteries and solar integration is possible in limited space of boat availability. This webinar today, we will focus on cost economics, which segments are really ready for conversion, what are the innovations happen, what business models, and what changes, interventions, policy side specifically needed to really grow this segment. With that, I would like to quickly introduce our experts today. I am honored to have Dr. Malini Shankar. She is Vice Chancellor, Indian Maritime University, a 1984 cadre IS, and she is Chairperson of National Shipping Board, and also was Chair of the committee constituted by ISA to look into solarization of the ships. Welcome, ma'am. Then we have Mr. Dean Jennings. He is Vice President Leclanche, heading their electric maritime division, based out of Scotland, and early electrical engineer supported British Royal Navy with long stint in maritime and automations and multiple roles. And then since 2018, heading and growing electric maritime in Leclanche. Then we have Captain PC Meena. He is a nautical surveyor come Deputy Director General Technical Division at Directorate General of Shipping. He is again a maritime executive with long experience before joining DGS in 2017. We have Mr. Mahdi Imad. He is Chief Executive from Maldives Transport Authority, the government division at Maldives, who is looking into and building regulations and controlling all transportation applications, including shipping. Welcome, Mr. Mahdi. And then we have Mr. Sandit Thandashari. He is founder CEO of Naval Solar and Electric Boards. Again, I think we have the two firsts in our panelists. Leclanche has developed the world's biggest all-electric ferry, Allen, and Sandit is credited to develop and deploy India's first solar ferry. So I think with this credible experts in this panel, I would now request Dr. Malini Shankar first to share her views on the importance of solarization and electrification of boats and how important it is. And then we will have our panelists share their thoughts. Thank you, and Dr. Malini Shankar.
Thank you, Mr. Bagdia. It's my pleasure to share the forum with the experts and to drive forward an issue which is very, very close to the heart. India as a country has probably, apart from Africa, the highest resource of solar energy, and it is still very untapped. But interest on solar energy is on a high. The Honorable Prime Minister himself spearheads the country's commitment to clean energy. In his address at the World Development Summit in New Delhi in February 2018, he referred to the International Solar Alliance as the single most important global achievement after the Paris Accord on climate change. The target of the National Solar Mission has been raised and set at 100 gigawatts generation by the year 2022. Although scientific research on solar energy has not been intense, India does have a few firsts to its credit. The Cochin International Airport in Kerala is the first and only airport in the world to be run completely by solar power for the non-aircraft purposes. It has in fact received the United Nations highest recognition for environment, the Champions of the Earth Award for 2018. We are witnessing a major transformation in the transport sector on land when it comes to electrical energy. We're also seeing Indian Railways taking initiatives to harness renewable power through solar roof panels to run electrical appliances on the trains and reducing thereby the fuel costs and contributing to a cleaner environment. A similar transformation is awaiting the shipping industry. About 10 years ago, a large ro-ro vessel called Auriga Leader was launched by NYK Shipping. This ship used solar power to reduce the generator load for lighting. A few years back, Planet Solar, the largest solar boat in the world, actually circumnavigated the globe. India's first solar-powered passenger ferry, Aditya, has been operating successfully for the past couple of years in the backwaters of Kerala. Based on its success, the Kerala government has actually ordered more solar ferries of 75 to 100 passenger capacity. Other states like Goa, West Bengal, Maharashtra, UP, and Telangana have similar plans. Solar power can actually find larger application in leisure and small passenger boats, fishing vessels, small harbor tugs and pilot boats, as well as coastal barges. It can be extended to seagoing ferries in the inter-island transport in Andaman Islands and in Lakshadweep Islands. There are about 2 lakh small boats that are engaged in fishing on the coast and inland waters of India. The government presently offers subsidies for purchase of the boat and for petrol outboard motor, that is OBM, in the initial stage, and provides annual fuel subsidy for operation of these boats also. The operational costs of solar powered or electric powered vessels have proven to be negligible in comparison to those powered by traditional fuel. Financial viability studies ought to compare life cycle costs of the boats, diesel versus solar power or hybrid power. As an incentive, comparable subsidy can be offered for capex of solar ships and boats. The environmental cost benefit analysis will of course strongly favor the solar powered boats. Choices need to be made regarding the appropriate category of vessel that can run on solar or solar hybrid energy and the relative benefits of new built solar ships vis-a-vis conversion of existing coastal ships or other ships to solar power. The option of solar photovoltaic versus solar thermal power also needs to be assessed for the chosen category of the vessels. Regulatory incentives and focus on solar research have ensured that cost of solar power generation has plummeted over the last decade across the world. With environmental issues tending to take center stage, solar powered boats will have immense potential in ecotourism places such as Dal Lake in Kashmir, Sundarbans in West Bengal, Chilika in Odisha, and of course inter-island transport in the Andaman and Lakshadweep Islands. Currently, vessels plying near the coast, including fishing vessels, are a source of both water and air pollution, which has a deleterious effect on health and environment of the coastal population. While the International Maritime Organization regulates marine pollution through international conventions such as MARPOL, we need to find practical solutions to counter the ill effects of fossil fuel propelled ships nearer our habitations where our fisher folk live. With a long coastline and ample source of solar energy, the time is right to propel solar powered coastal and fishing boats. Solar energy tariff has become competitive and there's tremendous improvement in battery storage capacities. With the right financial model and incentives, solarization of boats can be a viable alternative. In fact, the International Solar Alliance had its very first, this was a virtual first, and even otherwise, it was the very first solar technology summit on the 8th of September with participants coming from across the world. 26,000 people had registered. And when we talk of solar, it is not just solar panel, it could be solar farms, therefore solar energy converted into electrical energy. And there are tremendous technological advances taking place, and we should not miss the bus as a country with the tremendous amount of solar energy resources that we have. We need to take a lead to use the solar power in solar electrification of boats, fishing vessels, and coastal ships, etc. I certainly hope that the panel that has been chosen, it's a very rich panel, and I certainly hope the discussions will help us take forward the cause of solar energy or electrical boats in the interest of clean energy and in the interest of the lives of people who live near the coast and near where these boats ply. Thank you very much, and I look forward to a very healthy discussion in the coming hour.
Thank you very much, ma'am. I think it sets a wonderful context. Let's have our first expert speaker, Mr. Dean Jennings from Leclanche, and share his experience and where does he see the e-boats really kind of capturing the market. Dean?
Perfect. Thank you. Tell me if you can see my screen.
Yes, you can go into
presentation. Bear with me. You can see my full screen?
Yes.
Perfect. Thank you very much for the introduction. Good morning and good afternoon to you all from wherever you are. I'm going to give you an introduction into, of course, Le Clancher, and something very special that we've created in Le Clancher. Let your mind wander just for a second. What I'm about to share, or what you're about to witness, is a global first. What we've created is the world's first 100% electric ferry, and at the time, the world's largest. When I say electric, I mean everything. No hybridization, the drives, the motors, the thrust, the coffee machines, the lighting, everything. She can carry 200 passengers, 31 cars, or 5 trucks and 8 cars. She's non-polluting, no CO2, no sulfur dioxide. Let me tell you, I've sailed on her. And been in the Navy for quite a considerable time. Been on many ships. There's zero pollution, zero noise, significantly much more comfort for the passengers due to little or no vibration. So my goal in this presentation is to give you an introduction to Ellen and the technology that made her possible. First, I'll give you a little background on her heartbeat, the Le Clancher system. So before Ellen, as I said, I'll give you a little bit of an introduction. The company discontinued production of alkaline batteries and reconverted to lithium-ion technology manufacturing with massive investment over the last decade. Our state-of-the-art plant in Germany for both LTO and GNMC chemistries delivered in a pouch cell technology. In addition, we've invested in a new module manufacturing line in our headquarters in Switzerland to scale the current process ready for this electrical revolution. Yeah? The company has developed both the high energy and high power cell along with in-house software and management systems. And one of the key differentiators for our clients today is that we can deliver the full turnkey, vertically integrated system from cells to BMS, remote data logging from one system provider. We have 3 main business units in Le Clancher. The stationary business unit delivering renewable energies to the network as dispatch power. The speciality, making custom-made LV batteries for a wide range of demanding sectors such as medical and military. And finally, the e-transport business unit, of which I head up the marine division, providing high cycle life and high energy density battery solutions for marine, rail, and commercial applications. Okay, so why Ellen, and why is it relevant today? I mean, ocean freight or sea freight is the most common form of transport for importers, exporters, accounting for 90% of goods transported globally. So like it or not, we all consume and contribute to CO2 emissions. Now, IMO, International Maritime Organization, is United Nations Specialized Agency with responsibility for safety, security, shipping, and prevention of marine pollution by ships. And that society has set some ambitious targets for stabilizing mean global temperature. To attain these targets, it will have to reduce the CO2 emissions to near zero by the mid-century, and subsequently remove CO2 from the atmosphere during the latter half of the century. With Ellen, we have an option to significantly reduce the rate of consumption. So let me take you in a little bit further depth into some of the barriers that were tackled during the project. I think it was mentioned, yes.
Your window is coming in between your presentation. Can you click that arrow button? Your go-to.
Okay, yeah, okay, gotcha. Okay, is that better? No, sorry, I'll get it out of the way. Sorry, I apologise. Is that better? Can you see that better, yeah? Can you hear me? Can you hear me? Can you hear me? Can you hear me at all? Hello,
Yes,
can you hear me? You
we
can.
can hear you. We can hear
All
you.
right. Sorry. Okay. I will continue. I apologise. Okay. Yeah. So battery prices have decreased significantly for the last 6 years consecutively, and they continue to decrease. So we see that the opportunity for further projects such as Ellen are really quite viable. The largest the limited range of the pure plug-in battery operation. Ellen at the time was the largest battery capacity, allowing the Ferry or Ellen to sail some 10 times longer than other ferries. Now I know we're speaking about smaller units in this forum, but Ellen can travel 22 nautical miles or 40 kilometers between charges, so really quite significant. Safety in vessel operation and in operations as a whole was taken into account. Firefighting systems with lithium-ion technology being at the forefront. Redundancy, training of personnel, training from internal combustion engines to battery solutions. For old mariners like myself, it has been a challenge, and not least maritime certification of battery systems. There was no notification, there was no notation, there was nothing there to say that's what the benchmark is. So actually, in Ellen's, the system that we delivered in Ellen was the world's first to be certified for DNV-GL. Energy efficiency propulsion systems in ships. Using pure electric propulsion systems, the total loss in the propulsion chain was looking to be at 20 to 30% compared to 70-80% with conventional diesel operation. And again, charging infrastructure, and I think this is something that we really have to bear in mind with all EVs, including vessels, is that charging infrastructure needs to be there to enable the vessels. And in Ellen, we had a record-breaking charging infrastructure with a plug size of 6,000 amperes, something that was done completely bespoke at the time. So yeah, there were challenges, but we managed to overcome significant amounts of these challenges. So the technology that we produced specifically for Ellen was, and again, this is extremely relevant due to the nature of this forum, because size is we're not going to have a 4.3 megawatt hour battery system on a small vessel, but the scalability of this system is completely configurable. We can utilize both LTO and GNMC, so for high power and high energy systems. It has been certified by Marine Standards and DNV-GL, Bureau Veritas, Lloyd's Registers to date. And we've got an extremely high leading life cycle with regards to longevity for the system. So we wouldn't have to change this out too many times during the life of an asset. So the IMO regulations, you know, we have strict guidelines to reduce emissions in the maritime sector. The transition is underway, like I think has been mentioned. However, we've got a long way to go. You know, there has been early adopters within the Nordics and Canada, but the technology is there. We just need to really start to do more with it. I think, as we will see on this forum, and we can all do more. You know, solutions and innovation are there. We just need and want to change. I'll show you this infographic at the top just in a second, but just to mention there, the bottom infographic, if you see the light blue part of the pie chart, that's Norway in total. I mean, that's the total number of battery vessels globally. So, I mean, significantly, Norway are perhaps two times more than anybody else in the rest of the globe. So clearly, there is a lot of vessels circumnavigating the globe. So we really need to do so a little bit more from a global industry to decarbonize not just the transport sector, but specifically the maritime sector. I'm just going to show you this infographic that may or may not come to a little bit of a surprise to you all, but this is including international shipping and aviation. But when you think of pollutants, and certainly I do sometimes, is that, you know, we think of power stations, etc., as being some of the major pollutants. But clearly, from this infographic, you can see that transport is number one and continues to be number one. So we can all do something about this. And again, I'm going to go through some of the projects that have been delivered, and scale is of course key. I think when we're looking at other regions, I'm not going to go into any great depth here, other than the fact that to date we've delivered Ellen. We've got 45 megawatt hours worth of projects going to China for the Grimaldi lines. We have 2 projects in Canada delivering 1.9 and 4.6 megawatt hours, and a very interesting project with regards to High Seas 3, which is going to be a hydrogen hybrid. So, you know, there may be need for mixed fuel, and when I say mixed fuel, clearly solar can be a source of energy, but of course, so we're not going to do it all with one source of energy, especially when range is required. So hydrogen, solar, batteries, and all need to be taken into account. Again, another very important project, I think, globally, is a project that we're delivering 6.7 megawatt hours worth of battery, Leclanche battery, is Yara Birkeland. It is actually it's actually being commissioned as we speak. I have a team out in Norway this week doing that. It will be the first fully autonomous vessel, taking 40,000 truck journeys per year off the road. Now, if you can imagine taking 40,000 trucks off the roads, that certainly you and I, and it would make a significant impact to all of our lives, I believe, and this is just with one vessel. So imagine what we can do with further development in this sphere.
I will request it's 15 minutes. You can.
Yes, of course. Sure, I will look to wrap up. In short, I think we have significant opportunity to develop many technologies into many spheres of operation, from trains, trucks, buses, AGVs, tuk-tuks, and smaller craft. I think certainly we have the solutions are there now. We just need to grab them, I think, with both hands, and continue forward to implement them in projects. So there's a little bit of a bravery required, I think, from all personnel. Yeah. Sorry, you have a couple of minutes, did you say? Yeah.
Maybe a minute or two to make your important point.
Sure. Okay. I mean, what I wanted to actually show with regards to the smaller craft, we were looking at vessels of 6.7 megawatt hours and then extremely large systems. That's not we can certainly deliver on a much smaller scale. I've just showing you a couple of packs here at sort of 39, 45, 50 amp hours, which will be more suited to I believe more suited to the smaller craft that we're going to be talking about today. Okay.
Sure. Thank you very much, Dean.
Thank you. I look forward to your questions.
Yeah, great. I think yes, Ellen is quite a good ship in the big segment. Now let's understand a government side perspective. I request Captain PC Meena from DGS, Directorate General of Shipping, Government of India, to share how they have looked into this segment, what opportunities they see for electrification. Captain Meena, and if I may request sir, for time within 15 minutes, please.
Yeah, thank you, Rahul. Respected Vice Chancellor, Indian Maritime University, Chairman, National Shipping Board, ex-DG Shipping, Dr. Malini Sankar, Sri Rahul Bagdia, Managing Director, T-Manifold Business Solution Private Limited, and all other distinguished speakers, guests, ladies and gentlemen, a very warm good afternoon to one and all. And I hope that everyone is taking an utmost care in the ongoing pandemic to stop the spreading of the virus. And thank you, Sri Rahul Bagdiaji, for introducing me at the initial stage. I am Captain PC Meena and Deputy Director General of Shipping and working with the Directorate General of Shipping Mumbai. And I'm just going to present the government perspective, especially the Indian Maritime Administration perspective on the transition of the E-phase, E-electric boats, and the hybrid vessels and all other aspects from the government side. So I hope everyone is able to see the PPT.
Yes, please continue.
I think there is some problem.
You can see your screen, sir.
No, I'm able to not scroll down actually.
Just use your arrow key, maybe. Forward arrow.
Yeah, just a moment. No. Yeah.
Rahul, is it a PDF?
So the scope of the presentation is already initially briefed by Sri Rahul, and the overview of the existing boat and ships, their segmentation, quantum, and the different use cases in India, the current cost and viabilities, the potential to transition to the e-boats, analysis done on the quantum, and saving potentials and choice of the technologies. The government and the private efforts to enable the e-boat transitions, and key recommendation to create a national focus program on the e-boat segmentations. So before that we proceed, what we are doing is what international agencies are doing it. Let us just go back to the background of this cleaner ocean energy, how the origin has come from. This SDG, United Nations Sustainable Development Goals, agenda number 7 and 13 talks about the affordable, reliable, sustainable and modern energy for all. The agenda 13 talks about the clean climate change, the urgent action to combat the climate change and its impact. Then followed by the International Maritime Organization, as is spoken by my previous speaker on it, that IMO has started working on it. The initial IMO strategies on reduction of the greenhouse gases emission from the ships. So they have adopted a policy, a long haul policy, and they have suggested a numerous of initiatives to reduce this carbon emission and switching over towards the clean energy. So some of these important aspects which I will just discuss is the mandatory technical EEDI and the operational SEEMP. These are the technical aspects of a vessels. So they will monitor the performance of the machineries and how efficient it is, and then it is a continuous recording on board the ships. The second aspect is the technology cooperation and the transfer of technology, which all the member states of the IMO will share their technology through a common platform, such as this ITCP, the GlobeMe projects, MTCC networks. They are all international projects and the organizations through which they will share their technology. The third thing is the data collection system, which will be applicable from 2018 onward, which Government of India has already started collecting the data from all the ships on the consumption of the fuel, and we have started analyzing these data. The fourth aspect of the IMO is the safe operation on the onshore power supply to the ships. The interim guidelines have been agreed during the last session of the SSC subcommittee of the IMO between 2nd to 6 March 20. And the fourth of the IMO agenda is the long plans, the sailing towards zero emission container shipping, which by 2050, what IMO wants to achieve out of the ships is reduce the 50% reduction in the total annual greenhouse gases emission by 2050 and encourage efforts to phase out the greenhouse gases emission completely. Now, second is the third aspect is what are the renewable energy sources as on we are available. There are many kind of things, but only the sort which we will go through is the ocean energy, which includes the wave power and the tidal powers, then solar energy, which is the solar power, then wind power and geothermal energy. I will not go in details because everybody is from the same backgrounds and probably we all know all these things. Next step is what all ships we have, which we are planning to switch over this clean energy, clean fuels in form of a battery, in form of a hybrid system, in form of electric trains, or in form of a fuel cells. So number of Indian vessels that we have registered, which is all merchant vessels trading anywhere in the world, is 1429, out of which 457 is the larger vessels and around 1000 vessels which are operating on the Indian coast as coastal vessels or river sea vessels. The number of inland vessels we have approximately 20,000. The number of fishing vessels we have around 2 lakhs, out of which non-motorized is 53,000 approx. Motorized is 73,000 approx. Then mechanized is also 73,000. We have a sailing vessel of approximately 670. Now the next step is what are the potential for the industry. So here we have divided the vessels less than 400 tonnage, which includes the recreation, artisanal, small fisheries, tourism, passenger, break, landing crafts, barges, research, coastal patrol and security and pilot vessels. That between 4 to 10,000 tonnage vessels. These are the large landing crafts, small medium fisheries, domestic ro-ro, break bulk containers, tankers, trams, and 10,000 to 50,000 tons is ro-ro, deep sea fisheries, bulk container, tankers. So on the left side, we see what are the sources of the renewable energy, the wind, then solar, photovoltaics, then biofuels and waves. And these are the types. Out of the wind, we can have the soap sails, fixed wings, rotors, kites, turbines, and this RF stands for retrofit and NB is for new build. And these three dots shows that it is high potential, scores well on all three metric: economics, environmental, and social aspects. So 3 means it is very much probability that these can be switched over to soft cells. They can generate power through soft cells, fixed wings, rotors, kites, or turbines. So 1 is the limited option, but 2 and 3, yes, it is very high. And the yellow indicates these are our commercial operations. And green shows it is already been tested, this technology, and it is in use. So if we look at this, the bigger vessels we cannot cover through the solar photovoltaics, and this all are not applicable. But yes, here also we can have some sort of the hybrid through a electric train, which we'll discuss at a later stage. But I hope everyone is clear about this slide. So this 3 dots is very high probability, and the maximum probability of this clean fuel and the electric system and hybrid system is only on this recreational, artificial, small fisheries, tourism, passenger brakes, landing craft, barges, research, postal, petrol, and security. Then wave is very limited options. Then biofuel we have limited, means the medium potential, not the high potential. But wind is the highest one, where all kind of vessels can use, even the big vessels also there is a problem. And at the beginning, the madam has already spoken the potential areas for the solar ships, based on the ecological sensitive sea areas, such as the Sundarbans, Chilka Lakes, Dal Lakes, Varanasi, Udaipur Lakes, tourist boats and the port players, then Payaka Lake, then Mangrove, tourist Mumbai. And what government of India has done the feasibility study, especially with respect to the old vessels, new vessels, and different category of the vessels. And only I will take the one examples of the passenger vessels before the retrofitting. The feasibility study done by the. So these are the feasibility study we have done on this fishing vessels retrofit old, fishing vessels retrofit, fishing vessels, 10-foot boats, and 30-foot boat also we have done. Passenger ferry retrofits, and passenger ferry new. And what are the technical aspects we have considered during the feasibility study was the solar panel on ships with solar phones, terminals for charging the batteries, possibility of converting the existing vessels which operate on fuel oil, and exclusive solar hybrid and solar wind hybrid, etc. So the first one which I will share is the full technical study, specifically passenger ferry retrofitting. The passenger capacity is 75. The solar electric retrofit cost is around 152 lakhs Indian rupees. All units are in Indian rupees and lakhs. The trip distance we have considered is 3 kilometers. The number of trips is 30 trips per day, and distance traveled in a day is 90 kilometers. Speed 6 knots. Traveling time 8 hours. Embarkation time 12 meters. So these are the broad parameters which we have considered while doing this feasibility study. So I think this slide will be more better. So for this diesel ferry boat, when we are thinking of converting it to a solar ferry boat, the initial capex for this boat is 0. Whereas for this conversion, it is 152 lakhs Indian rupees. Then operating cost for the solar ferry boat is just 2 lakhs every year. 2 lakhs, and then around 5 to 10% increase every year. Then at the end of 7 years and 14 years, we need to replace the complete battery set, and which will cost around 38 lakhs approximately. Whereas the diesel ferry, if you look at the operating cost, it is 29 lakhs, which includes all kind of fuels, consumptions, all kind of other maintenance to the systems, and annually 5 to 10% increase. So at the bottom, if you look at the net present value, the operating cost for 20 years and with the diesel ferry boat is around 352 lakhs, whereas the solar ferry boat operating cost is 206.5 lakhs. So it is a huge difference in the operating cost. Initial cost for the solar ferry is very high, but after a period of 5 years, break-even period is approximate 5 years, and you will see that diesel ferry cost is 161 lakhs, and the solar ferry boat cost is also 163 lakhs. And after that, it is on profitable side. And at the end of the 20 years, you will be spending around 295 lakhs. Whereas with the diesel ferry boats, you will be spending around 962 lakhs. So that is a huge difference of 600 lakhs in the financial side. The economic analysis, Based on all the parameters given before, the crude oil saving is around 54,460 USD per year, and over a period of 20 years, the figures are here. Okay, environmental impact. Why everyone is switching over to the clean energy and to reduce the environmental impact due to the CO2, NOx, SOx, and particulate savings. So how much we can save annual CO2 savings is 1 lakh kg of CO2, and annual NOx saving is around 1400, and annual SOx saving is around 302 kg, annual particulate saving is around 38 kg. So all these are based on a 75 passenger ferry. And
Captain Meena, if you can wrap in 2-3 minutes.
yeah, what are the shipping efforts? What the government of India is doing is, we know this International Solar Alliance, and based on the International Solar Alliance guidance, the government of India has made a committee to promote the use of the solar powers in India in ships. Then constitution of a committee for developing the standards of the storage for the solar batteries and associated equipments, supply of the solar electric power to the visiting ships to India. The supply of the solar electric powers to visiting to India, we already initiated the action, and all in major ports are in the process of developing, providing these powers. And as on today, there are 2 major ports, Adani ports, Mundra and the Cochin. They are already started providing solar power to the visiting ships from the 1st November 2019 onward. And based on that, whatever we have a charging issues with the solar batteries, definitely it will be reduced. The second thing is the DG Shipping has taken initiative to issue the guidelines for the solar power supply at Indian ports. Then SOP, standard operating procedure, have been issued. So these are the issues which we have done it so far. And what challenges we feel in the future is the all electric and hybrid ships not ready for a long haul. But we have seen that, especially that presentation from the previous speakers, there are a lot new projects which are in pipeline and about to launch, and probably they will solve the long haul problem also with the hybrid ships. The other challenges what we feel is the organizational, structural, behavioral, market and non-market factors, unique and international nature of the shipping industry, underlying constraints and the factors that lie beyond the ability of individual states to effect incentives, policy and regulatory frameworks, limited research and development financing, particularly for the initial proof of concept technologies, is a major factor. Ship owners' concerns over the risk of hidden and the additional cost, as well as the opportunity cost of renewable energy solutions. Historically, there has been a lack of reliable information on cost and potential saving of specific operational measures or renewable energy solutions for this value. Concerning the market barriers, the fundamental problems is that of a split incentives between ship owners and hirers, limiting the motivation of owners to invest in clean energy solutions for their shipping stock. The benefit do not always accrue to the investing parties, and hence saving cannot be fully recovered. Risk adversity of investors in the sector. Of the known market barriers, the different classes and the scale of ships, the markets and the trade route serves, lack of access to capitals are some of the key barriers that must be addressed. And what we recommend to create a national focus program on the e-boat segmentation, and to address this, the green shipping policy and the R&D policy in shipping is under process. And in probably near future, we will see a green shipping policy in India and the R&D policy in shipping, especially with the solar. The technical feasibility study on the solar hybrid power in shipping, we have taken with IX members, but we need to have more feasibility studies so that policy decisions can be made based on a broader. Then subsidies for the solar boat constructions, enforcement of a timeline by which the eco-sensitive areas will not have ships or boats flying on the fuel. These are the few recommendations from our side. And with that, I will say thank you, and thank you everyone for listening.
Thank you very much, Captain Meena. I think it was very pointed and useful presentation of Indian landscape. Now let's look from our other speaker, Mr. Mahdi Imad, Chief Executive, Maldives Transport Authority. What is distinct vessel use case in Maldives, and where he believes and government of Maldives believe is the opportunity for e-boat presentation, e-boat start.
Good evening and good afternoon for those. I'm Marty Imad from Maldives Ports Transport Authority. My presentation will be about the transportation system here in Maldives and what are the types of ships we are using, and boats we are using, and a small account of Maldives. Maldives, as you know, is an archipelagic island nation with 450 kilometers to the southwest of the southern tip of India, and consists of about 1,100 low-lying islands scattered along a chain of 19 atolls. It stretches from north to south about 800 kilometers and is dominated mainly by the monsoons of the Indian Ocean. The temperature generally is between 25 degrees and 30 degrees. The socio-economic conditions of Maldives, the population in 2018 census reached about 515,696 people. Now it will be about 600,000 probably. And national economy is heavily dependent on tourism and fisheries. That's the mainstay here in Maldives. And 2019 GDP has been 5.73 billion. That's from the statistics we have got recently. That's 2019. The employment statistics now not being compiled as of today. What we have is a very old statistics, but now I think it's quite changed. And we have a big population expected working because there isn't enough of local people to drive the labor market here in Maldives. Now, transportation, because of our nature of islands scattered from north to south, the major mode of transport is by sea. Because we have islands, so many atolls, and there are islands, so many islands, and everybody wants to travel to take their needs to different islands or to sell whatever agricultural products or whatever products they have. So we use lots of sea-going vessels, different types of vessels. And also our tourism is based on sea, and I mean the beaches and all that. To move from one island to another, we use these vessels. The type of vessels we have right now here at Transport Authority are donis. Donis are kind of, if I have to show you a photo, I'll show you the photo next slide. Donis are small wooden crafts that takes people from one end. Then we have the launch as a speedboat. That means in other words, it's a speedboat. It's about 4,000. And then we have the ordinary boats, and we have barges, we have tugboats, we have landing craft, we have safari vessels. Safari vessels are vessels that are made like small passenger vessels for tourists to come and spend a fortnight or 1 week, and then that goes around Maldives, different atolls. Then we have oil barges, then we have luxury vessels, oil tankers, and so many other types. Now, show you a small, this slide will show you what a dhoni is like. This is how a dhoni is like, and then this dhoni takes people from one island to another. So we use this as a ferry also. There is ferry established in these islands, but not in a very coordinated, regulated manner. Some islands it works properly, but I think common intention is to make sure that we have ferries so that everybody from each island can travel to the other island. But towards the main city, Malé, where we have a very standard ferry which is very organized and works daily on a daily basis that takes people. But towards the other atolls, it's not so organized. But that's what the government is now planning in our strategic action plan to have a regulated, reliable, affordable ferry so that everybody. Then the next photo you can see, that's the launch. That's a speedboat that takes tour, mainly used for tourism industry, but for local industry, for people traveling far from Malé, the capital island, where they come for all their needs, and to the other atolls, they use this ferry. Then you get this big boat. This is also a mode of transport used for faraway atolls, people use this to take their cargo and then to travel with their cargo. Then the safari boat, the photo, you can see that that's the boat used by tourists for their holidays. Now the speedboat, we have two types. One is the wooden boat, then the other one is made out of fiber. And the speed is quite different from different. Sometimes it's from 9 to 13, the other one is way from 20 to 35. And the size of these boats are about 15 meters and above. And the safari boats are about 25 meters. And you can see on the background of this photo, you can see these are some of the speed boats which here in Maldives, which we use in Maldives. Now, the island ferry services in Maldives, the government subsidized ferry system is in operation in Maldives, and then you can see the atolls in the photo. You can see the ferry tickets from one island to island is about maximum 10 and to 25 rupiah, and these sometimes within we have intra-atoll within the atoll, and then between atolls we have. So it depends on where you want to come from where to where. These tickets depending from private ferry, there are private people providing ferry, and the ticket depends from 150 rupiah to 750 rupiah. Now, when I talk about Maldivian rupiah, the exchange rate for US dollars is about 15.42. So 15.42 Maldivian rupees is equal to $1 US. So you will be able to find out how many US dollars does it cost. The Greater Malay region, that means the capital Malay, you can see from the chart to the airport island and to the other island, where people, concentration of people stay here because this is where the government city, this is the financial center, this is the business center, this is where the port is, and this is where the main airport is. So this is the area where people mainly come for their business, commerce, for their medical, the hospital, all this. This is the greater. And then recently we got a bridge to the newly formed airport island, but then still people use the ferry. This ferry here is very coordinated. It's perfectly functioning. That is from Malé to Hulmale. Hulmale is the airport island and the extension of the airport island. Then we have from Malé to Hule, that is the airport island. Then we have from Malé to Ningli, that is the island, where satellite island of Malé, where people stay, live there. And then we have Malé to Tilakut. Tilakut is the industrial island which we are trying to develop as an industrial island that is close to Gulifar, which will be the new port in the future. Now I think work has already started. You can see this is the type of boats which we use in this photo. You can see there for travel. This is the ideal situation where I think there's a lot of sun here in Malé, and we could use the e-boat panels so that we can our boats will be sort of free of this carbon and all these emissions. So there is nothing much I want to add. If there's any questions you want to tell me, ask me, or I will be able to add. Thank you.
Thank you very much, Mr. Mardi. I think it will be great if Maldives can convert its capital city, Malé, arriving boats into electric ferries, primarily passengers. With that, I invite our next expert, Sandit, CEO from Revolt, who is an e-boat manufacturer. And Sandit will share his experience in India. Yes,
hi everyone.
Can see.
Yeah, distinguished panelists and guests. So today's session, I will walk you through our experience and learning, and I want to cover 4 sections. One is the story of Aditya and the challenges we faced. 2 is economic viability. Then what is the future holds, and some of the policy recommendations. So I will start off with the story of Aditya. So in 2013, when the Water Transport Department set out to, let me just hide this. Yeah. When the Water Transport Department wanted to make, at 2013, they had about 85 such diesel ferries. They're mostly made of wood and steel. And like all diesel ferries, they had these issues of air pollution, water pollution, noise, vibration. Is difficult for the crew as well as the people. There are also the smell of fuel. And at the time in Kerala, there was also an accident where overcrowding was an issue. So these are typical issues, but the most important issue for them was the operating expense. And this is where their challenge was. So it's a subsidized transport system like many places, and the revenue from that is less than the energy cost, fuel bill. So that's their challenge. And that is how they set out to see if solar can solve. But you cannot take an existing boat and then add solar panels and electric propulsion. It doesn't work, primarily because of the gap in energy. So you have to get certain things right. And there starts the challenges we faced. Now, before even we set out the technical challenge, we also had certain different kind of challenge in terms of the entrenched player trying to compare with the existing boats and saying that solar ferries of this kind may not function, right? So this was one aspect. So then, of course, statements where it's beyond the imagination. But why did they think was because you need to change the boat itself. So fundamentally, you have to change the weight of the boat by half. I mean, how do you do that? By using lighter materials, GRP, aluminum, etc. Plus, you optimize the structure design. And then you also need to reduce the drag to 1/3 by optimizing the underwater shape. So only if you do these two things right, then you can talk solar electric. This is if you are interested in the economics. Of course, as a technology, you can put a bigger battery and it still work. But in India, unless economics works, nothing works. So the key here is the third part is to get the powertrain right, marine approval, etc. And that is important because class approval, like our previous speaker mentioned, Dean mentioned about the DNVGL certification, which is exactly the one in our boat as well. Now, in addition, of course, in worldwide, it's common that the ferry boats are catamarans. That's because it's way more stable. So if you are designing a passenger ferry for India or in the region, you have to design for something which is overload. Like if you make a 75 passenger ferry, it should take at least 225 passengers, thrice its capacity, because you may have days when you will have that kind of overloading. So that's something you have to be conscious. And then unlike what Dean mentioned, in our view, NMC, LCA, NCA, we are trying to avoid for our own reasons. So we are trying to push for LFP or LTO. LFP we use when it's a single charging in a day. The battery is designed for the whole day operation, like Aditya. LTO we push in applications where you have multiple chargings in a day, and you need, it's probably because you need a lot more energy if you have only single charging, much bigger battery. So, and therefore that applications LTO is what we suggest. Now, typically we don't talk about redundancy in most of the inland ferries, but when we come with a product, we need not only meet the similar existing standard, we have to come up with something far better. And that's how, since it's a catamaran, you can make twin propulsion system, but make sure it's electrically not connected so that it is much more safer in terms of redundancy as well. And then, of course, monitoring, you need cell level monitoring and all the information available for the operator so that the person can decide whether it is safe to take the journey. So that's very important since it's a new technology. Now, this is just for just to show the construction stage. But one important challenge we faced at this point while the construction was on was the same set of opponents raised the level, so that I was at least forced to go to multiple vigilance officers to explain why the boat will work and not this, as the statement mentioned, that it will not work. So this is how the hull is joined, hull and deck are made and joined. This is an example of. So just before launch, even we had an experience of even a public interest litigation filed to stop the project. But thankfully, nothing happened, and we could launch the vessel and test the vessel successfully. And we could heave a sigh of relief that yes, the boat can run carrying 75 people. Now, it was inaugurated on 12th Jan 2017 by then Power Minister and Chief Minister of Kerala, and this is the boat in operation. So, as Malini Madam mentioned, it has been in operation for almost 3.5 years now. It has carried more than 1 million passengers. It has traveled about 75,000 kilometers and saved about more than 1.1 lakh liters of diesel, and saving the government of Kerala about 80 lakh rupees. And that is where the fundamental economics part is so crucial when we are setting out any project in India. So, and it is already established the economics, and the government is on record stating that Aditya has already achieved break even in the 3-year period. So this is the fundamental difference in OPEX, at least from $100 per day fuel bill. It's just $2.5 for the energy cost. This is also because 70% of the energy is from the sun, and that is very crucial, and I will explain why at a later stage. But you all know the benefit of solar and electric, so I'm not going into details, but only on the right side, if you see the why that sustainability is at 70% is important, at least for us. That's one thing we are conscious. And recently, the boat also was awarded as the world's best electric ferry as the Gustav True Award, and a few other awards as well. Now, coming to the crucial part of economic viability. Now, any project, it is a total cost of ownership that is key, right? So it is not only the initial cost, we have to factor the life cycle cost, as Malini Madam mentioned. So if you clearly, as also Mr. Captain PC Meena mentioned about the economics, there is no doubt about the economics at all. It is just some policy push, which I will explain what to enable this to replicate. Now, there is always a question once we decide electric boat. My view is that it must be as much solar as possible. Now, fundamentally, why we put solar along with electric boat is, one reason is, can we reduce the contribution from the grid? Because grid is not clean. Most of the grid energy comes from either coal plant or diesel plant, etc. So you want to reduce that contribution or offset it by having a shore plant. This is one reason why people do. The second reason why people put solar panels is, can we reduce the cost of power itself? So for that, you need to put a single large plant and feed it to the grid and take the power wherever your boats are. So that's one way to reduce the cost. But the most important thing is, can we reduce the battery size by increasing solar panel on top of the boat? And this is a very crucial question we all must ask, especially in India, where the economics is the matter, because most of the projects which Dean also mentioned is heavily funded by EU grants. So there is a lot of grants behind most of these projects. So the economics may not always be a concern, because they are interested in technology adoption. But that is not yet translated as yet in India. I'm sure policy makers are working on it. But if it happens, it is good. Even otherwise, if you can add the panels on an electric boat, what it serves is, it reduces the battery size. And that is very important, because unlike an electric train, your boat is not connected to the grid while energy is used, while it is in motion. So that means you don't have, if you have a source of energy which is provided while it is in motion, it will help reduce the battery size, and that is only sun for now, apart from fuel cell. But this is why we should put solar panels on the boat. Details, just Google ResearchGate and look for this paper, you will get it. And now future, one thing we have to all think when we talk of electric boats and energies, there are three fundamental things which drive the energy need. One is the speed of the boat, and that's the most important. Two is the distance it has to travel in a day. And three is the weight of the cargo to the boat weight. And this drives whether how much you can be solar electric. The speed is very non-linear in terms of energy intensity. Hence, if you are looking at a boat which is up to 8 knots, it can be pure solar electric. If you're going beyond 8 knots, then as it becomes exponential, So you are invariably ending up with solar hybrid, and the hybrid could be fuel cell as well, but hybrid for sure, not dependent only on solar and grid storage. This again is if you want the economics to work right and you are not worried about the capex installation, that's a different issue altogether. Now this is the new boat which is coming by end of the year. It's a 100 packs air conditioned boat for again Kerala government. Our experience of monitoring Aditya for the past 3 years and helped us to design the Aditya version 2. We are building 5 of them, and these are at least 20% more efficient. So this is broadly speaking some of the applications which we all should consider. Ferry boat passengers is a much easier problem to do, and Ro-Ro ferry is a bit more challenging, and I must appreciate the electric ferries for the carrying trucks which Dean mentioned. This is a slightly more difficult problem. The way we are approaching to do one in Kerala is to introduce again solar along with it. So about 30-40 kilowatt panels will be there to support the reduction in battery size. We are working closely with Shell Foundation for the fishing boat which is mentioned. There are about 1.5 lakh small fishing boats in India, and we can help the small fishing community making their life sustainable if we can come up with a solution which again has to be economical. Government can, instead of giving fuel subsidy, give subsidy for the electric boat itself, so that they have a much better lifestyle subsequently. Petrol boats is very interesting. You would think it's very fast, it can't be solar electric, but most petrol boats go at very slow speeds 99% of the time, and that is where a parallel hybrid can solve, because a normal water jet is very inefficient in extremely low speed. And then for large commercial ships, it is not solar, it is wind that can solve. So if you're working with suction sail and that will, it's not like the sail as in sky sail type, it's a suction sail, more like a Flettner rotor technology, which will give high thrust at a low footprint. And this for large bulk carriers and all, it means a 30-foot, 2-meter diameter cylinder on the structure, which can provide maybe 25-30% of the energy. Fuel cell is another, it's a technology is there, but the economics and the ecosystem for fuel cell is not yet there. Let me quickly go through the policy recommendation. One is a clear discrimination what the boat industry faces, or water transport faces, is in the FAME scheme, which is come exclusively only for electric vehicles on road, bikes to buses, nothing on boats. FAME 1 as well as FAME 2 now. So we should push for at least similar support for the boats. 2 is one reason why auto industry has picked up so well over the years is because of the financing. The banks will provide financing for an electric or for a car, basing car as a primary collateral. The boats, you still need to provide another collateral. So this is an issue, and that has to be solved before it takes in a big way. 3 is most of the central government firms, PSUs, Navy, Cochin Shipyard, etc., have very skewed payment terms, in terms of like you pay 100%, you get payment after you deliver a boat, which is usually custom made. It takes 6 months, and the whole financing burden is on the supplier side. So this is very skewed way. The state governments do not have such terms, so that has to be something taken care. And the GST rate, there is a differential for a diesel petrol car versus an electric car. It's 5% and 18-28%, whereas in boats both are same. So one way which DG Shipping and Ministry of Shipping can do is, if they can do that shipbuilding subsidy, which is now given for 24-meter and above boats, can it be given for solar at a smaller size, maybe 12-meter size boats? If you are solar, you get the shipbuilding subsidy. That's one thing is my submission. And lastly, I want to talk about import duty exemption. Government has a very clear policy to facilitate manufacturing of the battery in India. There's no doubt, and they have put a basic duty increasing over the years. But unfortunately, marine batteries are totally different, and there's nobody manufacturing in India, and nobody has even put it forward in the near term. The closest I know is 4C is trying, but until that is available, I suggest that please give import duty exemption till the day this happens. Just like Aditya, we got that facility, but it's a one-off case. It has to be a policy thing. So all in all, we are working at least to transform the water transport the way Tesla has done on roads. Thank you very much.
Thank you very much, Sandit. I think by the design innovation, the that you have been able to bring. I think we can rightfully call you Tesla of Indian ferries. So good, good work. Let me request Malini ma'am to go with the first set of questions for our expert panelist ma'am.
Thank you, Rahul. I will just have a few questions independent of this, and you can focus on the questions that's on the board. I just wanted to know from our guest from Maldives, Mr. Mahdi Imad, what would be the magnitude of the e-boat market in Maldives? And is the government taking any proactive policy? Does it have a proactive policy to promote renewable energy in these vessels?
Yes, actually, e-boat project will be sort of using e-boats here in Maldives will be a very profitable thing, I think, because almost all our travels from one island to another are used on boats. That means we have quite a lot of boats here in Maldives, especially the safaris which are used for tourists. These can be easily transformed on a commercial basis to be as e-boats because they are run by private people, and this tourism brings them a lot of revenue, which means they can easily transform the deck of these vessels for as e-boats. As for government's incentive, government wants to turn, and this is actually not our domain, it's the Ministry of Environment domain, so probably I think they are working towards how government could subsidize these issues. But so far, Transport Ministry is concerned, we have not so far got any indication of the extent to which they or their policies. So this issue I'll have to clarify from the Environment Ministry.
That would be interesting to know if the government comes out with a proactive policy, and very, very important for a country like Maldives to be eco-friendly. Thank you, Mr. Mahdi. I think there have been very, very comprehensive presentations, and many of the questions that we had in our minds have actually been answered. So I'm going to ask Captain Meena, your slide, one of your slides showed that wind retrofit is actually more feasible than solar, and even the slide showed that the feasibility for wind is actually more advantageous, whereas Sandit said he's a proponent of solar electric and not exactly wind, unless we are looking at a higher speed, in which case you go hybrid. So is there I would like both of you to give your opinion on this.
Yeah, regarding this, actually, ma'am, this was taken from the study carried out by the International Energy Organization, and based on what the feasibility study done by the IRS, and if we coincide as both, then the maximum profitability is, and the best part is the wind one. Which I have shown in one of the slide, wind is that there are 3 dots. If you have seen that, the high potential for that one. So this is what is the coincidence from the International Energy Association, I mean International Energy Agency. And the third is the solar one is the only the medium opportunities, but the actual practically what has been given and shown in the Aditya Ferry also, and what they are developing is they finding the solar photovoltaics and the battery system is more this thing effective.
Yeah, Mr. Tandaseri, do you agree with this? Because if that is the case, then the wind-powered boats should have taken off faster than the solar boats, and I don't see any.
Yeah, so I will try to put a perspective. If you are looking at inland ferries and smaller boats, passenger ferries, putting a wind system, like for example, which doesn't induce additional drag because of the structure itself. So on a moving body like a boat, if you add a wind turbine, so it will have its own drag. So that is an issue if you are putting a wind propulsion on a boat. So if you see all the large sailboats, the sailboats have a different approach to the wind, as in wind, using the wind. That is exactly what I told on the large commercial ships, right? Wind is the only way forward. So large commercial ships, you use that same approach, try to capture with a lower footprint with using cylinders like Flettner rotors, etc. So that is, wind is clearly an advantage in sea. There's no doubt, because the wind speed is much higher, and large ships, that is what will contribute. But on smaller boats, ferry boats, the issue is the footprint. How do you put that wind system itself without inducing the drag, and how do you operate it? I mean, simpler wind sails it's not easy to operate with low wind speed in inland. So we are not having two different conclusions. It's the same conclusion, but I'm telling from a very application point of view, the kind of boats in inland and ferries, etc. Wind is not possible from a very practical reason. But of course, you can do some smaller one. Even Aditya version 2, we are trying a smaller wind turbine, but that doesn't take care of the entire propulsion. Large ships, wind is the only way to do. Solar will, like you mentioned about the NYK vessel, it just give less than 0.1% of the energy need, even though it's about 150 kilowatt solar panels on the large ships. So it's just a question how much you can contribute in the context. So yeah, so small boats, definite solar is a way, unless you want to just do sail. But if you are putting passengers and other things, the footprint is already taken over by the cargo, which we call as passengers. So yeah, tricky that.
Thank you. May I request Mr. Dean Jennings, you had a slide which showed the total number of ships with batteries and a projection of that. And the graph showed that it is rising. Your projection is that it will rise till 2021. And between 2021 and 2026, the graph showed that it was plateauing. Any particular reason? Is that because 100% of the boats would be converted, or you don't see any support beyond a certain level?
I think it's the signed orders.
Yeah, these are signed orders. Yeah, as you said. So
signed
I mean, yeah. So I can only assume that. I mean, if we look at the interest in new vessels, then certainly I would see that would increase. So I think the bottom line is that operationally there are few and at the minute, but on order backlog there is quite significantly more.
Okay, there's another question in my mind. Whenever we try to promote renewable energy, especially solar or wind, there is an argument, a counter argument that's given that the amount of environmental damage that's caused by manufacture of that solar panel or the wind turbine itself is not taken into account while you look at the environmental advantage. How would you counter this argument in the case of electric boats, irrespective of whether it is solar, wind, or hybrid?
Can I answer?
Sure.
Please,
yeah, I had asked Mr. Jennings is answering. You can supplement perhaps. Otherwise, I will request Sandeep to answer.
The Dean can answer first. I will add.
Yeah. Mr. Jennings?
Yeah, I mean, certainly I think we when we're looking at this sort of project, we really need to look to the total cost of ownership of the project, but also to the planet and to people also. It's an economic project, but what cost of not doing something ultimately, I believe.
So I think I would.
Can I add the numbers to it?
Yes, please. Yes.
Yeah. So fundamentally, we have to remember one thing: when we set out to do solar or electric, we are not eliminating pollution. We are reducing. So the question is, how much are we reducing? If you take an example of a 20 kilowatt panel in Aditya as an example, each year is about 35,000 liters of diesel replaced by this 20 kilowatt panel. So the comparison is between a 35-ton diesel versus 20 kilowatt panel. It's ridiculous if people still think that 20 kilowatt panel is less polluting or is more polluting than a 35-ton diesel. That's one perspective. The second question, which is not told but implied, is 1 kilowatt panel is more expensive in its life cycle. Is it producing more energy than what it is used to make it? This is also a usual question, follow-up question. So we must remember that 1 kilowatt panel in its life cycle produces almost 35,000 units of energy in its life cycle. It's like daily 3.5 kilowatt, you take 365 days and 20 years. It's almost 32,000, you can say, kilowatt of energy. And the energy cost between the two, so 31,000 means if you take even 5 rupees is 1.5 lakhs. 1 kilowatt panel is, it's 20,000 rupees. So that's the difference between what it generates and what it, I mean, maximum it can consume. So clearly solar is way more environment friendly than the energy needed to produce. There's no doubt. IEC has also a lot of studies on it. I mean, they can always see it, but these are some of the quick numbers.
Okay. I'm sure Rahul has a few more questions that he would like to ask the panelists, but I would like to ask the panelists to answer just one question. What do you see as the biggest challenge to promotion of e-boards? Is it technology? Is it affordable technology? Is it the lack of infrastructure, or is it lack of policies? How would you? What would be the two major impediments in your mind?
I think I can probably answer that very briefly. I mean, I see it, infrastructure as being key here for me. I mean, as Sandeep has already said, the technology is there for us to propel these vessels, but we invariably will need to charge and recharge these, and the infrastructure costs can be quite significant in relation to the capex for a vessel itself. So we need to take all of these into account for sure.
Can I add?
Yes, please, Sandeep. Yes.
So in my view, the kind of vessels we are looking at India and most of the markets here, it's not even the infrastructure, because for charging of this, you don't need any major investment in infrastructure. It is those LTO and high charging, we may need infrastructure. For the slow charging, you don't even need infrastructure. Technology is there, no infrastructure. It is only that policy push. I mentioned briefly some of this policy initiatives that government can do to remove discrimination. I'm not even saying give special favors, just remove the discrimination. That's all. So it's just policy. You're not taking the cost of pollution. Simple. So you're not taking the cost of pollution, and it's just purely comparing the money, direct money, and not the indirect cost of pollution. So that's, if you just factor it, that's it. So all is.
Rahul, if you allow me just one question to Captain Meena. The Ministry of Shipping is coming out with a Vision 2030. Is there any input in that Vision 2030 regarding, eco-friendly shipping?
Yes, ma'am, I think it is there. I have gone through it, but I don't remember actually under which agenda it is included. But eco-friendly shipping, yes, we have included that.
I certainly hope if it's not there, it will, after this webinar, you will make special efforts to include more of it. Yeah?
Sure,
Yeah,
I'll do again.
Pardon?
Captain Meena, this is a chance to take it forward.
I think Captain Meena did speak about some green shipping policy, right?
Yeah, he mentioned about that specific subsidy as well, shipbuilding subsidy.
Yes.
Yeah, but if
so
the subsidy should be given, I'm wondering whether it's been made as a recommendation in that Vision 2030, in which case it will definitely be carried forward.
No, definitely. I will go through and probably we will suggest to include somewhere in the agenda. But I have gone through some green.
Dr. Malini Shankar, as a NSB chairman, you can also do a lot of push.
But that Vision 2030 is an official document. Whatever gets inputted into that goes into Vision 2030, which is going to be presented to the Prime Minister. So that's why that becomes the base document for future implementation. Sorry, Rahul, I've taken a lot of time. Please go ahead with the, I hand over the floor to you.
all questions were very, very relevant. So I think thank you for that. Just taking cue from Captain Mina's presentation, where he explored different use cases, and retrofitting was one of the an important thing that was getting highlighted in many of the cases. So I just want to understand, and given what Sandeep's observation was, like existing boat retrofitting, it's a very costly affair because it will be inefficient. So it requires really kind of working at the structure level, which he kind of proved with Aditya. So wanting to check, like, is retrofitting still an option that are can be looked into, Sandeep, for small boats? What we are
Yeah.
looking as viable options for India and Maldives, or you think it has to be all new boats only?
No, so let me clarify what I mean. So retrofit on any boards is technologically possible. There's no doubt. Now, when
Yeah.
we are sensitive to the economics, we have to be sure that the boat is already well designed, very light, etc. So if you have such a boat, there is no doubt retrofit will work. The issue is most boats are not designed with a solar or electric in mind, because the philosophy is different. You invariably want to make the boat very light. You want to make the drag so low. If you are doing a petrol engine or a diesel engine, you are not concerned between 20 HP or a 30 HP OBM or 50 HP to 60 HP. The cost difference is insignificant. So that the shipyards do not invest in the design to optimize that. But if you're doing solar electric, you are conscious of the last watt of power, the last kilogram of weight. So that is the only reason I said typical boards available are not easily retrofitted from an economics point of view. There will be a lot of good ferries available or boats available which are well designed. Those can be easily retrofitted.
Okay. Okay. So that market, Sandeep, you believe will kind of coexist, the retrofit
Yes.
of boats with the new boats. These two
Yes,
markets will kind of coexist also in the shipping space.
correct.
Denning, you have a viewpoint on this, Denning, the retrofitting of boats. Do you see this as a market in the countries where you are working?
Yeah, absolutely. And there is just to add to what Sandeep has said there. You know, there is absolutely the option. There is no you know, vessels last for 30, 35 years, and if the hull or from if a naval architect says that the hull is good for another 25 years, then we're not going to start afresh. We need to utilize what we have there, and the hull is a significant cost towards any vessel. So yeah, absolutely, it is feasible. It's easier, as Sandeep said, to do it from scratch, but it's definitely a possibility. And we always look to reduce the emissions from where they are in previous health. Well, that's the goal. So yes, in short, very feasible.
Great. And if I have to ask, like, maybe all of you, like maybe currently with the Government of India and Maldives representation here, what is the most impacting, easily doing first kind of an application which can really see scale, not just pilot of 5 or 10 boats. I'm talking of really a scale with feasibility. What applications you would see really doable in now with existing policy structure in India and Maldives? Maybe Captain Meena can share his view, followed by Mr. Madi coming from the government side, and then Sandit and Dean, if you can kind of support with your OEM views on that. Captain Meena.
So from DG Shipping, we are taking up this green policy. And the second thing is that with regards to the constructions and other aspects, that BIS, the Bureau of Indian Standard, is doing this technical study for preparing the standards, especially what kind of a new construction designs, as well as what should be the battery sizes, what should be the type of the batteries that will be feasible. So this study is under consideration. And
Meena, my question was different. My question is like, what is that one application or two applications very relevant to India, which you see very viable and ready for going for e-boats? Is it like the fishing boat applications? Is it like less than 50 passenger tourist application? So which application you think is the segmentation which you think will really grow faster?
I think if I can add to this is the vessels which can perform a shorter distance and which can have a lesser speed, especially less than 6 knot. As what Sandeep in one of the slides he said, if you perform a 6 knot speed, then it requires 20 kilowatts, but if you perform a 12 knot, it requires 200 kilowatts. So the vessels which are performing a less speed and the less distance and within a landlocked areas, so that segment will be definitely grow very fast.
Okay, and these are, sir, like only passenger carrying small ferries, or these are also cargo ferries?
These are primarily is the passengers because their weight is very less, and the second is the cargo. But for cargo, I think the best option what we can use the electric train sort of things where we can have a hybrid system. So depending on the requirement of a speed, then it can switch over automatically to the other system. Where there is a no speed requirement, then definitely it can go into a battery power mode. So that sort of a hybrid system is required. But initially at a first stage, it can go only the electric with the solar or probably a wind with certain combination, and with in the protected areas and sheltered waters.
Okay. Mr. Madi, coming to you, like what do you think is that one application which you want to do first and which you see scale in Maldives? Would it be like all ferries, passenger ferries coming to Male?
I think if you want to start up early and start up without a sort of block, without a hinge, the best will be to go to safari boats because then they are the people who earn money, and because the initial cost I think will be high in getting into this because you got to buy the panels and fix it and whims design a change of the ships and things. So this will be a capital cost which I know the only people will not be able to unless it's government subsidized or government does it. But if you want to come and roll it out immediately, I think the safari boats will be the best because these are the people who make money from that and they go on a slow speed cruising from one atoll to other. So I think that's the area where we can immediately do it. But I don't know if the government is having planned. Ministry of Environment should know more. I think more about business subsidy or the government funds are there or any other funds are there. Then we can put it on ferry because ferry is something, and still we are unable to get it properly sort of coordinated because of the kind of funds which required to start up a ferry to go regularly from one island to another.
Actually, that's a very interesting angle that you brought, sir, like which possibly we didn't have time and maybe we'll discuss it in other session. We will discuss more, maybe plan with ma'am as well on business models of right ownership, right infrastructure share to really improve upon the financing angle which Sandeep also brought out. So Sandeep and Dean, I think there are two different requirements that came out. Captain Meena was talking of low knot speed vessels, higher uptake in India, and because of private money and interest in Maldives, Mr. Madi suggested safari boat, which I am assuming is a higher speed, higher power, small size boats. What's your take, Sandeep, on this? What applications you really see government should focus where you see scale and impact?
Clearly, the easiest from a technology and economics point of view is where, as Captain Meena also mentioned, passengers are there, people are there. That's the easiest thing. So it's both public transport as well as tourism. So there are so many boats and places where it can work, both inland and near coastal, where the distances or speeds are not very high. Then there are places where the water distance is lower than the road. Like for example, Gateway to Alibag is a classic case, but the water distance is lower. So it's a case where always, even if it's high speed, it will still be lower fuel consumption on water than the road. So that is another kind of application. Fishing is a massive market. It's not the trawlers or those big boats I'm referring to. Those are the small fishing boat. There are about 1.5 lakh fishing boats, small size 30-footer in all across India. In Gujarat, it is called Pillana. So these kind of boats can easily be done if there is a scale economics. So if I start making one single fishing boat, it may be 15 lakhs, but to get the economics right, it has to be under 10 lakhs. Because normal boats are 2 lakhs, you have 2.5 lakhs savings, so you need a 4-year break even. So if you can get the pricing from 15 lakh to 10 lakh, which will happen with 100 number of boats order, the whole 1.5 lakhs is opens up, and that needs a push from government. But now at least we are working with Shell Foundation to see if it happens. But government is finally needs to give that initial hand holding in every technology. There's no doubt. And Maldives specifically, since I visited there, even that Malé to Willingili, the island where people stay, it's a very less than 1 kilometer. The current ferries operate less than 7 knots, and they're big ferries, and they can easily be this model, solar electric. I mean, because I've traveled and checked out, so that's why.
Great, Sandit. Dean, you want to add your thoughts on use cases?
Absolutely. I mean, I think I can echo what Sandit says there, and also Captain Meena. You know, where there is a paying customer, then clearly the economics are going to stand up, and return on investment is going to stand up much quicker. But also, we, especially in inland waterways, large amounts of cargo can be a paying customer as well. So sort of larger type vessels could also be a real source or a real key area to reduce the emissions on the roads as well, and utilize the waterways as a way forward. I think there will continue to be cost improvements and a wider adoption of the systems, not just in the Nordics but globally. So I think ultimately, if there are projects in the near to medium future, then we all need to have to look at the sources of energy that have been discussed on today's panel as options. We cannot continue, as I said, to go down the route of the internal combustion engines. The change and the transition has happened. It will only gather speed now.
Okay, I think this is good. As I said, there are more questions on design considerations, on engineering side, on range issues, on business models, on policy interventions. I think Sandit very clearly pointed out what policy intervention is the ask. Madam has supported inclusion in the 2030 mission document. Captain Meena, if I may say, have promised that this will get rightly included. And with this, I would say really this segment needs right kind of support from the government, and it does have good economics other than the environmental benefits. And I think the first cases have been established, at least in India. Maldives is yet to get seen its first deployments in e-boat space, but I think there are some thoughts and proposals going in that direction. So I really hope that this segment goes up, more deployment, and especially the impacting segment and mass segment like fishing, which Sandit has said that they have already started looking. I think Sandit, if I may request a very separate dedicated session talking only on that use case and inviting more innovations across the globe. So that may be something we can work with you. But with that, I would like to really thank Dr. Malini Shankar for her time. It was very hard day for her, but she still kept up with the commitment, and thank you, ma'am, for making it really very valuable. All our 4 speakers, very nice and very pointed share, and we look forward to engage with you in coming days under our hash grow electric boards, both globally and in India. And ultimate thank you to all our participants, and feel free to share your questions, and we will try to get them answered at the best. Thank you everyone, and have a good day.
Thank you.
Thank you.
Everybody.
Bye.